Hi everyone, my name is Chris Posch, as you said. I work for Teledyne FLIR. I've actually been in the industry for over 20 years, and I've managed a number of cameras development, Photon, Tau, Quark, Night Vision 2. I used to work with Richard many years ago, so I've done a lot of camera designs in the past, but what I'm here to talk to you about is FMVSS 127, the new regulation from NHTSA, and the test results that we did last month. So this, before we start, we have to understand what the problem is, and this slide presents the problem. And even the New York Times describes the problem is that in the US, pedestrian deaths are on the rise, and pedestrians are primarily being killed at night. And so how do we know this? Well, we look at the FARS data, and I have a slide showing you on that. But what we're seeing is pedestrians' deaths are on the rise, and we have to wonder, why are they on the rise? And specifically pedestrians, when you look at the data, 77% of the pedestrians are being killed at night. And so why is that happening? And I think you've all probably seen someone next to you driving, and they're not actually looking at the car, or they're actually looking at their phone. And I would call that distracted driving. I see it all the time. And it's particularly a problem in the US. And so this is the problem that NHTSA is going after. Pedestrian deaths are on the rise, and they're specifically happening at night. How do we enforce regulation to address that particular issue? So what you can do, and this is data that we looked at, and I'm sure NHTSA looked at it also, but 2020, this is the pedestrian fatality data. And what this shows is that this is a problem of speed. So initially, 0 to 25 miles per hour, very few deaths are happening. So the bottom, the x-axis is speed, the y-axis is deaths, and what we see is at 25 miles an hour and over is where the majority of pedestrians are dying. So we need to understand the problem at hand. How are we trying to solve the problem at hand? And so this is actually a direct quote from NHTSA. The vast majority of fatalities, injuries, and property damage crashes occur at speeds above 25 miles per hour. And if you know about the regulations today, the voluntary commitment for AEB, that's actually where the regulations are right now, currently. So to impact on this data, you need to increase the speed at which you test your AEB systems. And NHTSA increased the speed, and this, as part of this rule that's coming into effect, they increased the speed to 40 miles per hour, or 65 kilometers. And when they went through this ruling, we actually advised that, if you really want to address pedestrian deaths, you should increase this to 50 miles per hour, because you would address another 32% of the pedestrian deaths. So the summary of this slide is FMVSS 127 is attempting to address the problem which pedestrians are dying at speed and at night. So here's a little bit about the actual rule, Federal Motor Vehicle Safety Standard number 127. If you go into the test protocols of the FMVSS ruling, these are really what it boils down to. You have a daytime test, which is indicated here, a pedestrian walking across behind a vehicle, and the test vehicle coming at the pedestrian. This is done at 31 miles per hour. And then you have all these three other test cases that are done. The one with the most speed is this particular one here at 40 miles per hour. And they very smartly were addressing the problem, and so they specify that this has to happen during day and night. And I actually worked a lot with lobbying Congress on this with multiple interviews. And I specifically said, guys, if you're gonna address the problem, which pedestrians are dying at night and it's increasing, you need to specify what night means. Because currently testing, ironically, when they go through this nighttime testing, they put a stoplight right in the middle of the testing procedures, which is completely not nighttime. So what they specifically say now is 0.2 lux. And that is basically a moonlit sky. So again, this is an important slide because it tells you exactly what the OEM needs to pass coming up in the future. And So basically, by September 2029, if your vehicle doesn't pass these testing protocols, you could potentially not sell that vehicle in the US. And if you don't pass those particular test cases, you may be involved in a recall event. This is what you have to pass. So what we did, this is last month, what we did is we hired a company called VSI, and we said, VSI, please take our capability and bring it to American Center for Mobility and test it for us. Test our system, which we think the best AEB system. We think it's a fusion between visible, between thermal, and radar. If every car had that type of a system, we think we would put a serious improvement in pedestrian safety. So we took this vehicle. There was a convolutional neural network running on the visible, convolutional neural network on the thermal, and the HD radar was giving us range information. So it was a fusion between that system that we then went to the American Center for Mobility with. We then also chose 3 of what we thought were the best vehicles out there today that would do AEB. And I won't give you the OEM's names, but specifically OEM number 1 was a network of visible cameras running convolutional neural network. And there was another OEM vehicle that was running actually three visible cameras, 2 of them operating in stereo so they can understand the depth with the 2 stereo cameras. And then we had another OEM where we used a visible camera and a radar. And in this particular OEM's model was an electric SUV, a little heavier vehicle. So specifically on our test vehicle, we used a Sony IMX728 HDR 8 megapixel visible camera. So about the state of the art when it comes to visible cameras for automotive today. The thermal camera we used, there's 2 of them on the roof here. One's a 24-degree field of view VGA thermal camera, and another is a 42-degree VGA thermal camera. You can see them at our booth in the lobby. And then we use an HD radar for the depth measurements. Before I show you the results, it's very important that you understand the difference between what thermal sees and what visible sees, and that's why I included this slide here. On the left-hand side is a heated soft pedestrian target, and these actually exist today. You can buy them commercial off the shelf. This is a 4-active heated target that we simply rented from American Center for Mobility. And in this case, the heated pedestrian target is on. And to the right, you can see there is a target also. This is a pedestrian target, but it's not heated. So this is the difference between when you heat a pedestrian target and when you don't heat the pedestrian target. The center picture here, I'm showing, this is me here on the side over here, and this is the same type of target and another person here. What we're doing is we're using one of our FLIR cameras and we're calibrating the heated soft pedestrian target to look very similar to a real pedestrian. And on the right-hand side is a picture of the same heated soft pedestrian target in the visible spectrum with 2 real people on the left and right. So here is a comparison of some of the test scenarios that we did. We're coming right at the pedestrian. And on the left is that Sony IMX 728 HDR 8 megapixel with the low beams on. And on the right is the thermal camera, both running neural networks and using the radar to give the ranging information. What we found in our testing was nighttime was difficult for the visible cameras, and especially when you use low beams, and that the thermal camera had a very distinct advantage when it came to range and detecting the pedestrians. So here's the results. And I don't think this is probably a surprise to any of you, but when you fused visible, thermal, and radar, which is this line here, we were able to pass every one of the FMVSS testing standards. And the other OEMs had some failures. And when we went through this testing, this would have been 5 runs where we passed. If you failed, we stopped at 2. Mainly we stopped at 2, I think it's even specified in the regulations, but largely just to save the collisions with the pedestrian target and trying not to destroy our equipment. So if you fail twice, you're out, you get a red. I think what's interesting here is NHTSA excluded pedestrian crossing for a child at night. You can see it's clearly missing here. And you can also see what was interesting. We were surprised to see this. The most difficult test for these vehicles was actually pedestrian crossing from the test target, and the only OEM that was able to pass this was with their high beams on, other than our vehicle, which was clearly past this. And we actually a couple years ago sent our same vehicle, same capability to IHS, and said, okay, would you please test our vehicle? Tell us what you think about for Pedestrian AEB with thermal, because just last year they included nighttime testing in their requirements also. The very first thing they did with our vehicle was this test at night. So I think they pretty much know what OEMs are going to do and which ones are the most difficult situations. So I struggled with this slide because it's hard to give you guys an accurate value of range because with our vehicle, when we went and got set up for the testing at 200 meters, immediately our neural network was identifying the pedestrian. And this was with a 24-degree field of view and also the 42-degree field of view. So I could have put on here 200 meters, but that probably wasn't fair. So I tried to normalize the range estimates here to the best of my abilities, and that's what this item or this note here is. What we did is we took each frame in the visible, each frame in the thermal, and we stepped through with our human perception and said, is that a person? Is that a person? Yep, okay, that's a person. And so frame by frame, with the radar giving us the depth information, we were able to calculate and provide these range estimates. Now, what you should take home from this data is the thermal camera is at least 2 to 3 times the range of a visible camera at night. And surprisingly, it works quite well. Also, don't think about it just as a nighttime. It also works quite well during the day. So we took one step further and we said, okay, that's great. We can pass the standard FMVSS testing. What about like real life corner cases? And how do you really improve safety on a vehicle? So we devised these additional 4 test cases, and in this situation what we did is we put a vehicle on the other side so that its lights would potentially be blinding the oncoming vehicle that's going through the test. So this I would call more real world than the, for at least a thermal camera, a very easy test protocol that FMVSS stands. I think this is more real world, and so I have some results here too. We even included a lying down pedestrian, potentially like an injured pedestrian. So the point being here is these are more real world, and FMVSS does not actually test for things that thermal's extremely good at, like sun glare and shadows and weather and tunnels and things like that. So here's one of those test cases. I'll just forward right to the video that I hope will start. Here is the visible images. Here's the thermal images, and you can see right off the bat, the thermal is doing quite a good job of determining where the pedestrian is. And here, even though it is HDR, it's doing quite a good job of mitigating the blooming, but it's still quite hard to see the pedestrian. And so the take home here is you got a lot more range with thermal at night, and thermal is not affected by headlight glare. Another additional test case, this is the one I mentioned about laying down. Right now, our neural network would very likely already be detecting that as a pedestrian. I challenge you to see if the visible camera can detect that at nearly the same range. So the conclusions that we could come from this testing is we tested 3 2024 OEM vehicles to the FMVSS 127 standard, and all of those 3 OEM vehicles failed at least some of the nighttime test cases today. Only our system that had thermal visible, and radar was able to pass all of the test cases, and I showed you we were able to test a lot of additional test cases. Another conclusion I would get from this data is that the testing protocols, you really need to use a heated soft pedestrian target if you're going to involve a thermal camera. And I would contend that real-world test scenarios are going to be even more challenging than the FMVSS protocols. I believe that OEMs should consider using thermal cameras for FMVSS, especially when it comes to AEB for pedestrians. And I think it should be clear that the thermal camera provides the OEM additional safety beyond just the FMVSS. The things like Richard, you showed with smoke, animal detection, weather, those types of things also are a very key attribute for thermal cameras. And animal detection. We didn't talk about animal detection. It's near and dear to my heart. I think, Richard, you mentioned it, 2.1 million deer in the US alone. I actually have 2 or 3 times experienced that type of event, and it's a traumatic event to happen. And I challenge you to find another sensor that's more adept at detecting animals on the side of the road than a thermal camera. A LiDAR is going to have a very hard time with that in this situation right here. Radar is going to have a very hard time with that in this situation like here. And unless those headlights are illuminating that animal, you're not going to see it. Any questions?
I have a question. I'll try to speak loud. So when you're doing those testing, did you talk to IIHS or even 4A for that matter about changing the blue pants on the dummy?
Yeah, so it's a little irks me a little bit because you have blue pants in the visible spectrum, and when I've done a lot of data collection around the world. Most people wear black, so it's not terribly fair to mandate that the pedestrian soft target should have light blue pants. I think they should be probably black, and then I think the visible camera is going to have a lot more of a real-world problem with that. So I agree with you entirely. I have talked to IHS and NHTSA about these things. I've been just trying to get them to accept that they need to have a heated soft pedestrian target. Thankfully, there are COTS, commercial off-the-shelf mannequins now that address that thermal should be a thermal pedestrian, a soft pedestrian target should actually be heated. It's like doing the test when you're in black, you'd be all black. I mean, it's kind of the same thing. Yes, you have to heat the mannequin to look like a real person. Bill?
Hey, Chris. Basically, there's got to be a sensitivity with the thermal. Can you comment on what kind of signal to noise or any delta T or something else of what you need in a thermal camera to be adequate for this application?
So, yeah, so there's a question of
I got a second question here. I'll ask both of them and you can answer both. The second question is the weather conditions. So when I read this, I'm not seeing that we're not in the middle of winter and the snow on the side of the roads, or somebody's completely in a snowsuit that's not warm. I mean, how does this affect that ranging in your mind?
It's a good question. I know you know the answer. So about a tenth of a degree is what most thermal cameras are today as far as sensitivity. There's the response, and then there's also emissivity. I think it was Richard was talking about, difficulty if the pedestrian had the background at the same temperature. And I've had OEMs before saying, well, you can't solve that problem if you're, and I always say, well, we're talking about a tenth of a degree, which means I just put my handprint in there and I now see my handprint in the thermal, and the emissivity is different for that object. So as the military knows, it's extremely hard to hide from a thermal camera in almost all situations. But every sensor has got their pluses and minuses. And that's why when we devised what we think is the best automatic emergency braking system, we didn't just make it out of thermal. We said thermal, visible, and radar is the cheapest solution to solve FMVSS in all weather conditions.
Okay, we've got plenty of time before the break. So any other questions? Can I ask a question? Your sensor set, you've got 2 thermal cameras now. Obviously, thermal cameras are quite expensive. How is your discussions going with the OEMs about putting that extra cost on the vehicle?
So Our testing here involved a 24-degree field of view VGA camera and a 42-degree field of view camera, largely to see if we needed the narrow field of view on a VGA camera to see out beyond, like, say, 200 meters. But the 42-degree field of view was already at 200 meters. And so with a 24-degree field of view, you're classifying pedestrians out to 250 meters and beyond. So you're certainly getting a significantly more range with the thermal camera over the visible camera. You could potentially put a number of cameras on the vehicle, and that's up to the OEM's decision. They need to decide how many cameras they want to use. But certainly one camera solves FMVSS, and at a 42 degree.
Is that 42 degrees, does it do very well with cutting, a deer jumping from the side? How does that work?
So it really depends on the OEM, and we're happy to talk to the OEM about different field of views. When we designed our camera, it's called the Tura camera. You can see it at our booth. We designed 3 different field of views. We did a 24-degree field of view for those really long range situations. Those would be like a truck, a semi that's going down the road and wants to see 200-300 meters down the road. That would probably be a 24-degree field of view on a VGA sensor. For the vast majority of OEMs, the 42-degree field of view, which we also offer, that I showed here, would be fantastic for FMVSS and give you a pretty wide field of view. The other field of view we have is a 70-degree field of view, and that largely we decided on that field of view for what we think is coming, which is turns. We think, and I've talked to IHS about this, I said, everything that you've done so far is a straight line. When are you going to start adding turns? And this is 3-4 years back. When are you going to add dark and specify what dark is? So I've asked them, when are you going to add turns? And so it will come that because obviously not every pedestrian is killed on a straight path. There's turns going on. And you need to understand what's happening on the sides of you. So therein lies really the good value for a 70-degree field of view, and specifically unprotected left-hand turns.